Now today we are going to start shear force and bending moment diagrams. In this chapter we will learn what is shear force and what is bending moment, what is the effect of shear forces and bending moments on the given members or structure. Okay. Now here we have shear force. What is shear force? See, you are applying a force over here. When you apply a force over here, the cantilever beam which is shown here, it can shear and the material can break and go down, is it not? So if I want to draw it in a line diagram, I have a line diagram here. You see I have applied a force here, F. This force, what it can do, it can cut the beam at any point, at this point or at this point or at this point, this point, any point. So what would be the force which will be available for shearing of this beam? That is F. If it is 100 newtons, then at this point also 100 newtons can shear off the beam. At this point also it can do. At this point also it can do. So at any of these points it can do. I'll just show you one picture of the rivet. Just see here. So you have this rivet. In this rivet you can see that what we have let me take the color. Some other color is, yeah, black is okay. So now you see a force is applied on this point and the force is applied at this point. So what is happening now? See, at this point, if you see here, what is happening? The material is, the rivet is shearing off at this point, is it not? It is a single shear, of course. You can have multiple shears also. Now here, this is what is happening. Okay. Now let us go and just see what is the bending moment. Okay, a bending moment is what? A bending moment is nothing but, mathematically speaking, it is force multiplied by perpendicular distance. If you have, let us say, if I am holding something over here in my hand, so this is my hand. In this hand, if something is held over here, if some load is kept over here, this is the shoulder. So now if this distance is known, let us say this distance is 1 meter, okay, and this force is, let us say, 100 newtons. Then what is the, if I call this point as A, if I call this one as B, what is the bending moment? Bending moment M is equal to force multiplied by perpendicular distance. What is perpendicular distance? Perpendicular distance is 1 meter. So this becomes how much? 100 Newton meter. Okay. If I want at this point, if the same force, let me change the color. Now if I have another force over here, something like this, and if this distance is how much? If this distance is half meter or 0.5 meter, then what will be the bending moment? Bending moment M will be is equal to, if this is also 100, so then it becomes how much? Now forget this one. The first one you just forget, okay? Because now I shifted the force over here, understand? Let me remove this. I am shifting the force to this point, okay? So now what will happen now? Bending moment is equal to 100 multiplied by 0.5. So see here, this becomes how much? 50 Newton meter. So the effect of bending moment changes from one place to another place depending upon the length of the distance of the force from the point where you want to take the bending moment. Okay. Now let us come to this picture. Let's come to this picture. In this picture, if I want MA, what actually is MA? MA is bending moment at point A. What is the distance? My reference is also this only, means the distance is 0. L is what? L is 0 over here. So what will happen? Bending moment is nothing but 10 multiplied by 0, that is 0 Newton, kilonewton meter. There is nothing there. Now if I come to this point, point B, if I come to this point B, for this force F of 10 kilonewton, the distance is how much? The distance is this distance. So that is MB is equal to 10 into 2, that is 20 kilonewton meter. Okay. Now if I go to this point, point number C. So what is this distance? This distance is nothing but 2 plus 3. That makes me 5. Okay. MC is 10 into 5. That is 50 kilo Newton meter. Okay. This is the bending moment. Okay. The definition is also there. Moment, it is the tendency of the force to bend or twist an object. Okay. Now let's go to the effect of shear forces. Now see here, you have a structure over here. So in this structure, there is a possibility that the structure can fail at this point. The structure can, let me take some other color which is lighter in nature, you can understand it. Okay. The structure can fail at this point. See, the material can shear off over here. Okay. So similarly, so many places are there. This place is there, this place is there, all the joints. Understand? Not only joints, it can even shear off in the middle also. Okay, because of the forces acting on this structure. Say shear force diagram. It indicates me what? It indicates the shear forces withstood or resisted by the beam along the length of the beam. Bending moment we already said. Okay. Now let's go to the next one. When we want to draw the bending moment and shear force diagram for a given member, we should always follow a sign convention. Understand? So now let us say I have a beam over here like this. Any beam for that matter. What happened to this? Any? Oh, it's not writing. Okay, the color is wrong. Okay. So now let us say I have a beam like this. In this beam, there are some forces acting over here. There are some forces acting like this, some like this. If I want to find the shear force for this beam, let us say I want to find the shear force at this section, X, X. Okay. Whatever forces are there on the right side, I have to follow a sign convention. What sign convention I follow? I will just write it over here. See, this is my section XX. So anything acting on the right side downward is positive. Okay. Anything acting on the left side of the section upward is positive. See, if you write right side downward, left side it should be upward. Okay. And then now make the opposite of it. The opposite of it is here like this, is it not? It is negative, and on the left side downward is negative. Okay. This is the sign convention for what? This is the sign convention for shear force diagrams. Okay. So now here if I add one force, let us say if I add one force over here, let us say there is one force over here. This is acting up. Now on the right side, what are the forces? Let us say this is 10, this is 5, this is 15. So on the right side, what will happen? This will be right side upward is what? Negative, is it not? Minus 15 plus 5 plus 10. This gives me what? This gives me 0, is it not? So if I want to write shear force at xx, shear force at xx will be 0 because addition and subtraction is giving me 0 result. Okay. This is the sign convention for shear forces. Now let us go for the sign convention of bending moment. Okay. Anything which is, whether it is on the right side of the section, first let me draw the section. Okay. This is my section. Anything which is trying to bend the beam upward, whether on the left side or right side, we don't care. Okay. So then we take it as positive, any bending moment. Anything which is trying to bend the beam on either left side or right side downward, we will take it as negative. This is the sign convention. Understand? So this is what we have here. He shows you here. See, whether on the left side or right side, it is trying to bend upward. So it is positive. He shows you here. See, sagging bending moment. Sagging means something which is happening like this. And the negative bending moment. So something is becoming like this, we call it as hogging. Understand? See here, see here. So this is what I also have written on the right side. This is the sign convention for bending moment. It is very essential. Before we start any uh, problem, we need to follow this rule. Now let us see here what are the different types of beams. Here you can see I have a cantilever beam. In case of cantilever beam, you have only one support on one side. Okay. Whereas a simply supported beam has supports on two sides here. See, you have a support like this, support like this. Understand? Here you can see the beam can move like this and like this. There is no hinge here. There is no hinge here. Understand? It is just a simply support. So what will happen? The beam is just resting on two supports. That's all. Now next beam is what overhang beam. In case of overhang beam, you can see here you have a support here. You have a support over here. The beam is hanging on this side. So if you are applying a force over here, if the force is much more, then what will happen? The beam can just pivot on this and move like this. Okay, it can happen like this. Understand? So these are the three types of beams we are seeing. There are others. We are not worried about it. For your class, this is enough. Now here you see the loads. What are the different types of loads you have? He is showing you over here. In this case, you have got these loads. These are all concentrated loads. They are acting at a point, is it not? They are also called as point loads. Like you can see in a structure of a building, it is like columns, understand? Amud. So the load is acting on the column. So now here, this load, the second one is what? Uniformly distributed load. You have a beam. On this beam, you have kept small blocks, tabuk, you can say, concrete blocks, okay? Each block, let us say each block is, let us say 10 newtons. If it is 10 newtons each block, then how many blocks are there? واحد اثنين ثلاثة أربعة خمسة ستة سبعة ثمانية. You have got 8 blocks over here, okay? 8, each block is 10 newton means 80 newtons you have got. If this length is, let us say, if this length is 1 meter, then I will say this is total is 80 newtons, is it not? But what I will say, I will say it as 80 newton per there. This is the weight. If you want for half meter, you can easily find out what is the length, I mean weight for half meter length. Somewhere over here means on this side it is how much? This will be, this weight is how much? This weight is 40 newtons per half meter. Okay, or generally 80 newtons per meter. But here in this case, it is 18 newtons. There is no meter here. It is acting concentrated at one point. And here you can see in the third one, it is uniformly distributed load. You are starting from 0 and slowly you are increasing the load. Okay, this is uniformly varying load. Okay, we will solve problems on these three different types of loads. Okay, we have got the problems now. We will just talk about the problems in the next video.